Okay, part 2, here we go. We're going to look at the second derivative test, and I don't think I had you write it out yet, so we're going to go ahead and do that. Now, the second derivative test, I will go a little faster than you can go probably, so just stop the video and write it down, and then turn it back on. Alright, the second derivative test, before we get into it, we want to write out our formal definition. Although we have talked about it, let's look at our formal definition of concavity. So, right, informally, we have discussed that concavity is where the graph goes from the smiling direction to the frowning direction, or vice versa. So here it is in math lingo. If the second derivative of x is greater than 0 for all x on an interval, then f is concave upward. And then if f double prime of x is less than 0 for all x on an interval, then f is concave downward. So that's our definition for concavity. And also in that discussion, previously, we were introduced to a point of inflection. So we're going to define that as well. A point of inflection is where the concavity changes. So it can go from upward to downward or downward to upward. So we would have the second derivative is going to be positive to the second derivative being negative. Is that backwards? So that's a concavity. Now upward is positive. And downward we would have the second derivative is positive. Negative. I just did that one. To the second derivative positive. Alright, so that's talking about where an inflection point is. And we talked about that already, but I want you to write it down formally. And there are just so many points which are possible for points of inflection, where the second derivative is 0 or it doesn't exist, is where we are going to look for possible points of inflection. So sometimes we find some imposters, but that's okay. All right. So that's sort of a recap of what we've talked about previously. And now I'll give you the second derivative test in formal lingo. The second derivative test looks like this. Here's the intro. Let f be a function where f prime of c equals 0. So we have the first derivative zeroing out. So we're at a critical point. And the second derivative of the function exists on an open interval containing c. So notice we don't have the discussion about where the first derivative does not exist, because we need to use the second derivative. We can't find the second derivative if the first derivative doesn't exist. So we're limited to only using those spots where the first derivative is 0. Let f be a function where the first derivative is 0 and the second derivative of the function exists on an open interval containing c. So, number 1, if f double prime, second derivative of c, is greater than 0, then f has a relative min at that point, f of c. So, that means that if the second derivative is positive, we have the smiler. So that means we're talking about a relative min at that point. And the second part, if second derivative is negative, less than 0, then f has a relative max, because we know second derivatives that are negative are frowning, so they have maximum points. All right. We're not done though. There's a third part, and that is if the second derivative at point C equals 0, then the test fails. So the function may or may not have a relative max or min at x equals c, but the second derivative test cannot tell us. So second derivative at c equals 0 means we have to go and use the first derivative test to tell what we have. All right. So that's all of that blab that you have to get down. See if I can get it all in one shot here. Probably not. I don't know if you could read it from all in one shot. Hold on to your socks. Yeah, can't quite get it all in at this angle. All right, well, your job is to get that down, and I do need to check and see that you're being faithful in writing down these videos. All right, to conclude today's video, we are going to look at a real-life example, which we've been mostly theoretical about the second derivative test. So let's go ahead and give us some meat behind it here. All right, here is the example that we want to do. And I want to zoom back in or out. I do need a cameraman. My fingers aren't working well today. All right, let's use the second derivative test, and we're even going to write that out. Use the second derivative test. And again, what do you think I'm going to say? It's all, what are we testing for when we have these creatures? We have these creatures when we are looking, we're using these tests to find certain creatures, and they are to find relative extrema. And that's just another word for max and min. So relative extrema. Relative max and relative min. So never lose sight of what we're looking for when you hear the first and second derivative test. All right, see if you like this test better. Let's start with this function. That's a 5. All right, write down this function. Negative 3x to the 5th plus 5x cubed. To use the second derivative test, we have to first take the first derivative. All right, hopefully you agree with me on that. And I would like to know where the critical points are before I can continue and find the second derivative test. The second derivative. So keep the second derivative in mind, but we're going to need the critical points. So let's use the first derivative to find them. That's where the first derivative is 0 or does not exist. Since this is a polynomial, it is smooth and has no sharp turns or holes, skips, or jumps. So it is no place where it does not exist. So we're going to go ahead then and look at where it zeroes out. So setting the first derivative equal to 0, I'm going to factor it. Both terms have a 15 and an x squared. When I pull that out, I'm left with an x squared and a minus 1. So setting each of those, I'm going to factor that difference of two squares and set each of those factors equal to 0 and solve. So I end up with x equals 0, x equals 1, and x equals minus 1. All right, so we know that our critical numbers, those are going to be where our max and min can occur. So we're going to look, there's our possibilities. But it is the second derivative that's going to help us get there. And we could stop there and use the first derivative test, but we're going to go back to the first derivative and take the second derivative. So becomes what? Minus 60 x cubed. That's the first term. And the second up there is 30x. All right, so there's our second derivative. And we don't have to do anything else with it. So let me draw my line that I love to draw, my sine line. All right, so this, I'll start with f prime. And what I'm interested out of f prime is just where were the critical points. And you'll recall they're still there, I think, in the screen. 0, 1, and -1. So remember on my sine line, I put the name of what I'm graphing here, and these are the x values, and this is where the first derivatives are 0, the critical points. So that's really all I need because I'm not using this test, I'm using the second derivative test. So I'm going to draw another line, and this is going to be what's happening with the second derivative. So I'm interested what's going on at these points in the second derivative. So I'm going to take the point -1 and put it into my second derivative. And when I do that, there's my second derivative. So I'm going to find f double prime of -1. So I'm going to throw that into that function. And when I do, I get -60x cubed plus 30 times -1. And once again, I don't really care what that value is, but it's sine. I might have to go the distance on that one. So this gives me a -1, positive 60, and a -30. So this gives out to be 30. And that is a positive value. So I'm going to indicate that my second derivative at this point is +1. So that tells me right away, do I have a relative min or a relative max? Well, we know the second derivative is smiling at that point. So that test tells us, that positive number tells us we have a relative min. So do you see how the second derivative test becomes quicker a lot of times than the first derivative test, where we would have had to try a value on this side and this side? All right, so let's go over here where the second critical number was x equals 0. So I'm going to put that into my second derivative and find f double prime of 0. And that I can do very quickly is just 0. Uh-oh, epic fail. You'll recall on the second derivative test that when it zeroes out, the second derivative test cannot tell me whether this is a max or a min or neither. So we will have to go back up into first derivative land and test at this point. But let's hold that for a second and finish. Here at x equals 1. I'm going to put this value into the second derivative and find f double prime of 1. So I'm going to throw 1 into this function here. And I'm going to get -60 times 1 cubed plus 30 times 1, which does give me a negative number. So let's go ahead and put a negative value there in the second derivative, which means we have a frowner, so we have a relative max. Okay, I don't think I went 14 minutes. Okay, just in case I have, I'm going to do a part 3 for this, and I will be back.